everyone. Today Emily and I will be explaining buoyant forces and Archimedes Principle.
If you've ever heard somebody refer to buoyancy, you probably know that it's the thing that makes other stuff float. So, we're going to be talking about buoyant force, which is actually the upward force that is exerted on objects when they are in water or any other fluid. So, if you have a boat that's floating in the water that has buoyant force that is keeping it up above the water. If you also have a rock that sinks in the water, that would have buoyant force on it, but there would be more gravitational force on it, causing it to sink. So if you can see that force body diagram there, up in the left corner, there is gravitational and buoyant force on it, and obviously there would be more buoyant force on that object, which is allowing it to float. So this equation, which is buoyant force equals rho times g times v, is the equation of Archimedes' principle. So that rho is the fluid density, which is the mass per unit volume, or rho equals m over v, where m is mass and v is volume of the fluid that the object is in. So there would be a different density for water in, say, syrup. Like syrup would be more dense. Obviously, that's like a bit of a thicker fluid. You can kind of think of it like that. And then there is also gravitational acceleration, which is 9.81 meters per second squared. And then V equals fluid volume, and that's the volume of the displaced fluid. So when there is, say, you put a rock in a cup of water, the water level is going to go up when you put that rock in the water because there is water being displaced, and that displaced water is what that fluid volume is. And the reason why you would want to use this equation is you can figure out that buoyant force, and if you know the gravitational force, you can compare it, and with that, you can determine whether or not an object will be able to float.
Archimedes was a Greek mathematician and physicist. One day, as he sat in a tub, he noticed that the water spilled out from the tub once he sat down. This helped him realize that the displaced water, the water that fell out of the tub, must have the same volume as him. Archimedes' principle states that the buoyant force of an object is equal to the weight of the fluid displaced by the object. We can see from the picture that when the object is placed in the water, there's a change. This is the displaced water, and this is what we're looking at. Here's a photo to help visualize the concept. We can see the upwards buoyant force and the downwards gravitational force. Don't forget, the density, rho, in the buoyant force equation refers to the density of the displaced fluid, not the density of the object. How does Archimedes' principle work? Well, here we have the original equation for buoyant force. In the equation, the density is multiplied by the gravitational acceleration and also multiplied by the volume. We can rearrange the original equation to be buoyant force equals density times volume times gravitational acceleration. Since density equals mass per unit of volume, it can be rewritten as mass equals density times volume, which relates to the mass of the displaced fluid. We can substitute m equals rho times volume into our original equation for buoyant force. The buoyant force is equal to mass times gravitational acceleration. mg, or mass times gravitational acceleration, also equals weight. So, the buoyant force is equal to the weight of the displaced fluid and can be rewritten as such. This is why Archimedes' principle says that the buoyant force on an object is equal to the weight of the fluid displaced by the object. Here's another picture. So when an object or substance is put into a fluid, an upward force is created. This is a buoyant force, and it is opposite to the vector for gravity. But why do fluids exert upward forces on objects? Well, when objects are submerged in a fluid, there is a pressure difference between the bottom and the top of the object, just like in the picture. fluid pressure increases as an object moves further into the fluid, so the pressure exerted down to the top of an object will be less than the pressure exerted upwards to the bottom of an object. The equation for water and or liquid pressure is P equals rho times G times H. Again, rho stands for the average density of water, G is the gravitational acceleration, and H is the height of the water, which is basically the depth of the fluid. The bottom of the object is deeper in the fluid than the top. So the bottom is literally just deeper than the top part. So the upwards force is greater than the downwards force, because the pressure increases as we go deeper into the fluid.
Okay, so I'm going to be doing a little demonstration of how objects with the same mass can either sink or float based on their shape. So I have this little boat here that I made out of aluminum foil, and then I also have this little stack of pennies that has approximately the same mass as it. If I put this boat in the water, it will float, but if I put these pennies in the water, they will sink to the bottom. And also, if you're thinking about a boat, you might see something on it where, there's a weight limit on it, so you can only put a certain amount of things on it. So if I were to put a certain amount of pennies on it, at some point it will begin to sink. You can see it's going lower and lower in the water until you have enough coins here to actually make it sink. But yeah, now it's filling up with water and it'll sink. So that is why when you're on a boat, you don't want to go over the weight limit. Okay, so now we're going to be looking at fluid density. So this is the rho value of the buoyancy force equation. So there are different fluid densities for different fluids. So for olive oil, it would be something like 0.9, and water, it would be 1, and honey, it would be 1.4. So you can see that as the fluids get more dense, they have a higher fluid density value, and that would make the buoyancy force also increase. So that would mean that the denser a fluid is, the more buoyant force it will exert on any given object. Okay, so now we're going to be looking at why do ships float. If you've ever wondered why those big Navy ships that are tens of thousands of tons are able to float, but a rock that is less than a pound will sink straight to the bottom, it comes down to the buoyant force that is on them. So this can be altered by 3 different factors that we've looked at. So the fluid density, and you can't change the fluid density, say these are both in water, you can't change that, it will be the same for all of them. And then the gravitational force, you obviously can't change that. And then there is one last thing, and that is the volume of the fluid displaced. So by changing that, you are able to make either more or less buoyant force on an object. And so when people are building ships, they are considering, well, how much water is going to be displaced by this ship in relation to the gravitational force that will be on it, and they want to make sure that their ship is shaped in such a way, designed in such a way that the buoyant force that is increased by increasing the water displacement is enough to counteract its weight. So they do this with different design features such as air pockets that will allow it to take up more space essentially in the water without increasing the weight of it. Whereas this steel ball here is, it has the same weight, but it doesn't have those design features, so it will sink straight to the bottom. As you can see also in these force body diagrams, there is the same amount of gravitational force, but there is much more buoyant force on the ship, which is allowing it to float. And since there is very little buoyant force on the steel ball, it will sink.
Thank you for listening to me and Emily explain buoyant forces and Archimedes Principle. I hope you learned or understood something. Thank you.